am Azad Kasi. I'm here with a tutorial on standard servo motors. Today we want to take a look at the position mode in standard servos. We'll be examining position mode together in standard servos. What I did was use an encoder, and through the encoder I apply the pulse. We send it to the drive, and when I rotate the encoder, as you can see, our servo motor also starts to rotate, and we can even control its direction of rotation. So we want to today get familiar with the wiring method and the settings we've made in the drive. Well, as you can see, we used a signal cable that is connected to a terminal. And as we explained in previous tutorials, there are some settings that need to be done in the drive. Let's review those settings as well. I will also give you some explanations about the wiring diagram. There we use terminals 10 and 19 and connected pulse and direction to our encoder, and we also use terminals 18, 19 and 20, terminal 18 as an emergency stop and terminals 19 and 20 as CWU and CCWU respectively. We also connected terminal 47, ensuring proper configuration and secure attachment to one, and we are using this as the servo on. We are currently using it. Terminals 49 and 50 were also connected to the positive 24 volt input. Now let's go ahead and also check its other settings in the system. We want to ensure that everything is set up correctly and operating as expected before we proceed further. The previous tutorials. In previous tutorials, we mentioned that the standard LS drive can operate in 3 modes: position mode, speed mode, and torque mode. Today we want to carefully review the position mode together. So in position mode, when the standard LS drive wants to operate in this mode, position mode, it requires an external pulse, meaning it requires an external pulse source in order to operate. This external pulse source, this could potentially be a PLC, or it could be another type of controller that is able to generate pulses for us. For example, if we use an LS PLC, we can use the pulse output and direction terminals of the board and connect the pulses generated by the PLC to the LS drive. Alternatively, we can also use a rotary encoder as a pulse source. Just like in the video that was shown to you at the beginning, as you saw earlier, we used an encoder as a pulse source, and when we rotate the encoder, though it produces pulses, its output generates a brief electrical pulse signal for us, and we connected this pulse to the LS standard drive. In position mode, we can use another device. This component is called a ball screw. Its main function is to convert rotational motion, which means spinning or turning movement, into linear motion, which is movement in a straight line for us. For example, when we want to achieve a linear movement, such as instructing it to move by exactly 1 centimeter or to move by just a few millimeters. For instance, the ball screw makes this possible. We can use a ball screw for that. The ball screw is connected to the motor shaft and can convert rotational motion into linear motion for us. The second mode we mentioned, in which standard LS drives can operate, is the speed mode. In speed mode, when we set the drive to this mode, our motor starts rotating at a constant speed, and there's a very important point to note, and that is, as the load on the motor increases, our speed does not change, meaning that the speed of the motor is not related to the load. So when we set the drive to operate in this mode, the speed remains constant. There's no longer any need whatsoever for an external pulse source. To set the drive in this particular mode, we either use digital inputs or analog inputs depending on the specific requirements of your application, which are available on the servo itself. And now in the CN1 section, in previous lessons, we covered the analog and digital inputs, and we definitely introduced them to you. So the important point to keep in mind is that when our standard LS drive is set to operate in speed mode, it actually does not require an external pulse source by utilizing the analog or digital input signals that are already present on the standard drive itself. The drive can receive the necessary speed control commands directly without needing any additional external pulse generating devices. We can control the motor in this mode. We can control it. Well, there's a parameter in LS standard drives. This is called parameter P0-03, which is a specific setting that we need to configure. If the value of this parameter is set to 0, it indicates that our drive is operating in what is known as torque mode. On the other hand, if the value of this parameter is set to 1, it means that we're currently working in what is called speed mode, and if this is set to 2, then you're working in what is known as position mode. There are also some combined modes available. We'll explain these different modes in more detail in the upcoming tutorials. Well, in the previous tutorials, we talked a bit about the C1 parameter. We gave you some explanations and said that in servo standard drives, there is a section called C1, which is a very important preset port and has various parts. We covered the digital inputs for you in the previous lesson. Now, today we want to talk about pulse input. Pulse input is used when we want our drive to operate in position mode. Through this section, we can input our pulse into the drive. So, if we want to generate a pulse using an external pulse source, like a PLC or an encoder, for example, and apply that pulse to the servo drive, we can do this through this section, which is in CN1. All right, pins 9, 10, 11, 12, and 49 on CN1 are all related to the pulse input. We can apply electrical pulses to the LS standard servo drive in two different ways. We can apply pulses. One way is through line driver and the other is through open collector. The line driver has a voltage level of 5 volts, but the open collector has a voltage level of 24 volts. If we want to use an LS compact PLC to generate pulses and to control the servo drive through a PLC, we definitely have to use the open collector mode. This is specifically because the output voltage level of the compact PLCs that we are able to use in PLCs is designed to be compatible with open collector circuits. The LS transistor type is 24 volts. But sometimes, for example, we might use an expansion card, which is a type of hardware that provides us with a line driver output. Or, for instance, we have a controller, and in this case, the output of the controller is a line driver. So we need to use this line driver wiring. Today, we want to get familiar with line driver and open collector wirings. Alright, pins 9, 10, 11, 12, and 40. These are fixed pins on the CL1 that we can use to apply pulses. Now, whether our input pulse is line driver or open collector, you have to use all of these pins. Pin 9 is positive PF, pin 10 is negative PF, pin 11 is positive PR, pin 12 is negative PR, and pin and the common pulse type, which in both methods, these pins are actually the same. Well, now suppose, for example, we have a PLC whose output is a transistor type NPN, or for instance, a PLC, like a PLC from the XEC or XBC DN32H or DN64H series. We know that these PLCs are transistor type and are NPN. If we want to use these PLCs, Or for example, another brand of PLC that is also NPN transistor type and can generate pulses for us and has position mode, we want to use that PLC to connect to the LS standard drive and send pulses. We want to send them to the servo drive. Let's see how the wiring for that would look like. Let's say that pin 49, which is our pulse com pin, in the case where we're using an NPN type output, our pulse com should be connected to the positive terminal of the power supply, so we need a 24-volt power source. We connect its positive terminal to the pulse com, which is pin 49. And we use pins 10 and 12 of our servo motor specifically for the pulse. We do it like this. We apply the pulse to pin 10. Pin 12 is specifically for our direction signal, and we do not use pins 9 and 11 in this setup. If our PLC, which stands for Programmable Logic Controller, is of the NPN type, we only use pins 49, 10, and of course 12. You simply connect pin 49 to the positive terminal of the power supply. You send the pulse to pin 10. Pin 12 is for direction. Direction means the direction of the servo's movement. Now, if our PLC is of the PNP type, let's say, for example, we have a PLC that is of the PNP type, and if that PLC is from the LS brand, its compact PLCs could be XEC or XPCDP 32 or 64H. So in this case, we say that when our PLC output is of the PNP type and we want to send a pulse from it and connect it to the LS standard drive, we definitely need to use a resistor. The resistor that LS itself specifically recommends here is that for the output, in fact, if our PLC transistor is operating at 24 volts, we should use a 1.5 kilo ohm half watt resistor. All right, the wiring becomes much easier for us here. That is, for example, suppose the XBF PDCF2A card has clearly marked for us the PF positive, PF negative, PR positive, and PR negative. You connect the PF positive to pin 9 of the CN1 terminal. You connect the PF negative to pin 10, the PR positive to pin 11, and the PR negative to pin 12 of the CN1 terminal. So in this case, wiring becomes much easier for us, and we can use this method. Well, that video which you saw at the beginning, now we want to explain more about that. We mentioned that we used a standard LS servo drive and we want to set it in position mode, and using the encoder you saw, generate pulses and send those pulses to apply them to our servo drive. In the digital input section of CN1, we used pin 48 for stop and pin 18 as emergency stop. We assigned CW and CCW to pins 19 and 20 and used the servo on so that we assigned the servo motor onto pin number 47 of our CN1 input. And as we explained in the previous tutorial, we can define the function and logic for each of these pins that I mentioned here. And for more information, you can refer to the tutorial. Our previous tutorial, which was about these digital inputs, where we explained this in detail. We explained exactly how we can set the function and logic for digital inputs. Thank you for your attention to the explanation about changing the function and logic.